Alright, welcome back to this new and exciting math lesson. Now, what we're going to be doing today is learning about composite figures and surface area. Now, if you have never heard of composite figures, or if you've never listened in one of my math lessons for composite figures or surface area, then this will be new to you. However, I hope that many of you can recall exactly what these things are and how they are to kind of function. Now, if you haven't, one of the easiest ways that I use to remember how to work through these things is that I am working right here with 4 problems, and they kind of look all like mashed up kind of shapes. And that's the truth. So I like food, and that's kind of how I am. So the way that I remembered is, for example, with number 1, I have a messed up part of a cookie batter, which is kind of like before the actual cookies like cut into nice little shapes and thrown into the oven. So what I want to do is I want to like chop this all up into perfect shapes, perfect cookies, perfect shapes. Now, for number 1, what we're going to do is we're going to work through this. We're going to cut it up into a perfect shape so it's perfect to go throw into the oven. Now, number 1, a couple of things. I notice that I have right angles, and I have a slanted line. That slanted line normally tells me about a triangle, which is in this case true. So for number 1, the shapes, I used a rectangle, and used a triangle. Now, number 2, I'll give you a little bit of a pause to kind of catch up with this. Number 2, I notice once again that I have what is to be the right angle identification box on the top and the bottom. And then I notice that I have this little curvature right here at the end. Now, anytime that I see that little curvature, I want to think, yes, circles. So what I want to do is I want to kind of come in here and identify that. Now what I have is a rectangle. And this is not an actual circle. Okay, I can understand that you would want to spit off a circle right off the top of your tongue. However, this is not a full circle. It is only a half circle, or for a proper word, semicircle. Yeah, a little bit of a pause to allow you to write all of this down. And number 3. Now, I'm wanting to look up at this shape right here. Now, a couple of things. There are not only the little 90-degree box identification, right angles, there's also these little things called tick marks, little hash marks. Now, what that tells us, if you can recall, is what? Yes. It tells us that they are the same length. Now, anytime that you have 2 identical same lengths, you should identify the fact that there should be a square associated with that, okay? Because if this side and this side are the same, and then you have the similar right angles, you should identify that this is a square. So, I used two squares and another square for a total of 3 squares. Now for my final project, what we're going to do is we're going to have a kind of a mixed up shape. Now, there are multiple ways to do this. I will identify 1. Now, looking right off the top of this, I could, for example, see this little bit of a rhombus underneath. That is a rhombus. And then I noticed the 90-degree angles. I could turn this into a rectangle, and then I can finish it off with a triangle. So I use the 3 shapes: a rhombus, a square, and a triangle. Now this will be the next side to this activity, and I will work through this now. Now, before you follow along with this video, what I would hope for you to do is to pause the video right here, because what I want you to do is I do not want you to work through this and follow along. I want you to kind of challenge yourself and then use this as an answer key. But you can follow along with what I'm going to do. Now, the diagram models the length from the center of the turbine to the tip of its blade, which is closest to the total area covered by the blade when the turbine makes 1 revolution. Now, a couple of things. I'll have to pick the paper up real quick because I'm having trouble seeing that. I believe that is 32. I'm going to check my... It is 32. So if you're having trouble reading through this, that is 32. Now, what ends up happening is this makes the shape of a full circle. Now, if I want to know the area of a circle, then what I would have to do is find that on my reference chart. So while I'm attempting to get my reference chart out, I would ask for you to do the same. So what I want to do is I want to go through and I want to identify where is the area of a circle. It is A equals pi r squared. So I have pi 32 squared. Now, if you can remember back to PEMDAS, you have to take care of parentheses, exponents, then your multiplication or division, and then finally with your addition or subtraction. Here we have an exponent right here, this little 2. So I need to make sure that I do 32 times itself. And I end up with 1024 pi. Now I can look over here and look. One of the things that I notice is I don't have any type of pi associated with my answers, so that this is not my final answer. So I need to go one more time. Remember, with 3.14, I don't need to line up my decimals, but I do need to recall that I have a 2 decimal place value. Now, my final answer is 3,419.36. So if I want to round this, I would end up having 3,419. Now it's asking what is the closest to the total surface area, which indeed would be A. So there's my first answer choice. And for the exit ticket, so that way you know for a fact that you have this, land and use a semicircle, which is this, a rectangle, which is this, and a right triangle to form the figure below. So the triangle is there. What estimate is the best for the area of the figure in square centimeters? So I need to identify what is the area of this total shape. Well, 6 times 4 is 24, so that gives me the area of this. Now in order to find this shape and this shape, I'm going to have to do a little bit of extra work. So here I know radius, divide this in half, so it would be 2, so the radius is 2. Area of a circle, if I recall back to my first problem, would be this. But because it's in my circle, I have to divide it later on by 2. So if I throw this in, I have 2 squared pi, 4 pi, which is roughly around 12. But I'm going to work through that really quickly. So there we go. Now I need to divide that in half. I'll end up with 6, 4, and 8. So $6.48. Now this one's going to do a little bit more work. Not only do I have to divide it by 2 because it is a triangle, but I also have to find this missing side, which is from here to here. Now I know that this side is associated with this, so it is just 4, and this would be 10 minus 6, which would grant me 4. So I know that this is actually half of a square. So 4 times 4 is, yes, 16. Divide that by 2. I get 8. Now I just need to add up these numbers. 24, 8, and 6.48. Excuse me, I put the line in the wrong spot. So I need close to 38.48, which is D. So with that, can I give you a close-up view again, once again, of this final paper, because I was unsure of where the paper ended up throughout the video, and here we go. So just a quick recap, reflection of this. Make sure that you grade this and turn it into the white turn-in tray that is on the small rectangular table on the carpet. And thank you, and have a good day.